So, welcome to this video about the the coin rotation paradox. Yeah. So, I decided to create this video because I saw a very interesting video about the rotating coin paradox. Yeah. And basically it asked a question. We have two coins, yeah? A bottom coin and they're both the same size. So, circumference of both coins and the length of this outer surface is the same, yeah, €2 coins. Now, the question is, when I rotate the top coin around the surface of the bottom coin, so the bottom coin stays still, we rotate the top coin around the bottom coin, then the question is, how many rotations will the top coin make? Yeah. Now, I thought once, right? That's what I thought. Now, that's wrong. And I will show you how many times it rotates. So let's rotate the coin. I will try to avoid any slippage of the coin. So there we rotate it. Oh, do it again, slipped. Now it's at the bottom and you see it already rotated once. Now halfway, now rotate again, and of course you will imagine, you can understand that it rotated 2 times. So, well, for me that was interesting because I think for more people that's interesting because it doesn't feel very natural that this happens, but basically it is very natural that this happens, and that's the reason I created this video, because I searched for some explanations why this happens, and I found some very mathematical explanations, and I don't really like that, because for me visual explanations are the most powerful. That's how I think. Let's move the coins away and let's take a straight gear and let's take a circular gear, which is the coin. Basically this is the coin, and the length of this straight gear is exactly the circumference of this gear. Now, that means because we are now traveling on a straight line, we will probably rotate only 1 time, right? Yeah, and that makes sense, right? For me that made sense, because each point on the surface of the circle is has touched the straight gear, so therefore it rotated exactly once, because it travels over a straight line. Okay, and that's the thing. If we take a coin the same size, so this gear, instead of traveling over a straight surface like when using the straight gear, we travel over a circular surface. So we have to add the rotation of this surface to the total rotation of this coin, but because of course it traverses the complete surface of this coin, that's 1 rotation, but it also moves around this rotation, so it adds, so rotation is also added to the coin at the same time. So 1 extra rotation should need to be added. So we have 1 time rotation of the surface and the rotation of the path it follows. That's 2. Okay, I hope that makes sense. If not, hang on with me, because I'm going to explain it even further. So instead of a circle, let's take a square. Yeah? We can see a square as some kind of circle. We have a straight line, and because a rectangle is also a circular shape, we have a 90 degree turn here, a 90 degree turn here, it's 180, another 90 degree turn here, 270, and another 90 degree, 360. So 1 complete rotation. Now if we take a coin, yeah, This is still the circumference of the coin. If we now rotate this to the end, of course, rotate exactly once, right? But now, watch what happens. Here, you rotate around the corner, which adds a 90-degree turn, but you see that the tooth of the gear, so the gear itself is not really moving, so we are not traveling an extra point on the gear, you see. So we only add rotation of 1/4 turn, and then we go down again, add another turn. So, and there we have again 90-degree turn, and then we have another, and we have another for 90-degree turn. At the end, finally another 90-degree turn, and we land at the start. So how many times did this coin rotate around the square? That's that's not a good question. How many rotations did this coin make when it was traveling around this square? So that's 1, 2, 3, 4 times. 4 times the circumference plus another rotation of these 90, 90, 90, 90 degree rotations. So 4 plus 1. There's the plus 1. Always plus 1 because we plus 1. So if instead of a square we would have a triangle, we remove this and this, we would not add 1. No, we would have this rotation here is 1. We have 2 rotation, and you see we only have 1 rotation here, so we add only 0.25 rotations, a quarter rotation, you see, because it only moves an extra quarter rotation here. Okay, hope that makes sense. Now let's take this one step further. Let's look at another gear, this one here. So we still have this small gear. The small, if we look at the outer diameter, this gear fits in there 1, 2, 3 times. Okay, so if we rotate around the surface, we now know it's the complete distance covered, which is 3 times the circumference of this one, so three rotations plus 1, because we travel around a circular surface. Okay, there we go. That's 1, that's 2, that's 3, and that's 4. 4 times, okay. Now another question. What would happen? We have an inner, here we have an inner gear. The inner diameter of this gear is 2 times the diameter of this gear. What would happen if I rotate the gear here? How many rotations will this gear make? Well, I was just thinking logically about this, because this is the inverse of this for me. So we have a rotation from the outside to the outside, and we have a rotation in the inside. So instead of adding 1, I would suspect we have to subtract 1, right? That means 2 times we travel to 2 rotations to surface, but we subtract 1 because it's an inner gear, an inner rotation. Let's see if that's correct. That means that this gear would rotate only once. Let's see if it's correct. So, see, rotate only once. The interesting thing to notice is that the distance it traveled here around this surface is has something to do also with the rotation, but there's two concepts. So we still travel. We travel, though the surface of this coin is still, and each point on the coin is still touching one point here on this circumference, so two times. So the distance traveled is still 2 times the circumference of this small gear, right? But we're talking about rotation, so please think about rotation and the followed path, the length of the path, two different things, and that also puzzles some people. So, okay. Now, I hope you are still with me. Now I will take a different shape which I created for this tutorial, and that's this shape, because we now understand that an inner circle subtracts and an outer one adds, right? So this one fits in there 2 times, and here it fits in 3 times in the big, surface. So now the question, if we move from here along this path to here, how many rotations will this small gear make? Yeah, so again, this is half a circle, and the path here, if we take it as a third, so this path here, the half circle, is exactly the circumference of this small coin, yeah? And here on this side, this one, the coin fits in 3 times, so it's 1.5 times the circumference, yeah? Okay, now you can pause the video if you want, and try to figure it out for yourself. Unpause again, and I will give the solution. Okay. Now, let's see. I hope you figured it out. So what happens? So now, here we have a half circle, right? This coin fits in 2 times. So, because it's a half circle, it will make 1 rotation, right? 1 rotation. It would be the complete circle, and we have 2 times the diameter. It would be 2 rotations, but it's only a half, so it's 1 rotation, yeah? Then we're not taking into account yet this curvature, this path shape. Come to that later. Now it's 1, and here this coin fits in 3 times, so 1.5 rotation, right? Because no matter if it would be a complete circle, it would be 3 times, 3 rotation, but because it's the half of it, it's 1.5. So 1.5 plus 1, 2.5. Now we add 1.5. This one, right? 1.5? No, not 1.5. A half, because it's just a half circle. Nothing to do with the diameter. It is nothing to do. It's completely had nothing to do with the diameter. It's just the shape. So 1 plus 1.5, 2.5 plus a half is 3. And we have to subtract here. This one is an inner shape, so 3 minus a half, 2.5. So that's the final answer, 2.5 rotations. Let's see if that's correct. Let's see, okay, there we go. That's 1 rotation, that's 2 rotations, and that's half a rotation, 2.5 rotation. Okay, hope that makes sense. Now let's take another shape. It's a more difficult shape. Same concept applies to all shapes. The same concept also applies to any spline path. So as long as you can figure out the amount of rotation being added on the path of a spline, and you know the length of the path, you can figure out the number of rotations. It's very easy once you understand the concept. Okay, now let's take this. I call this my the paradise bird. It's a funny shape. So now we have a smaller gear, this one. Yeah, let's take a nicer one, nicer looking one, better black dot. So there. Now you can still let's see if we start here. Yeah, we start here. We follow around this path. We end up here. Now the question is, how many times does the small circle rotate? This one is this coin size, right? And here, this is again this size, but it's only a half part, yeah? And this one, this big shape here, is the big circle. So it's the big, it's the big, so it's the inner gear, but it's the diameter of this big outer gear, and it's also 3/4 of a size, yeah? So here, this little circle fits in 2 times. Here, in this inside, it also fits in 2 times. And in the outside, let's see, 1, 2, 3, 4, 5, 6 times. Indeed, fits 6 times. So 2 times, 2 times, 6 times, right? Okay. Now, you can try it again. Put the video on pause, and I will give you the explanation. The solution, I mean. Now, the solution to this problem. Here we have 3/4 of a 3/4 of the circumference, 3/4. So rotation 3/4 of 2 rotations is 1.5, right? 1.5 rotation. Now here again 2, but the half of 2 would be 2 rotation. That's half. So 1 rotation, 1 plus 1.5 is 2.5 rotations, and you have the 3/4 of the big one, which is 3/4 of 6 rotations, because circumference of the big circle is 6 times the smaller one. So 6, 3/4 of 6 is 4.5. So we have 4.5 plus the 1 is 5.5. 5.5 plus 1.5, this one is 7. But we still have to subtract and add from the path shapes, right? So we subtract, we add from the 7, we add 0.3/4, this shape. 7 3/4, then we add a half, we subtract a half, because we are going inwards here, so that's 7.25. And here we subtract 3/4, so 7.25. That means 6.5 rotation. So 6.5, that's the answer. Let's check if that's correct. Let's move the shape. What do we say? Ah, yeah, we start here. It doesn't matter, but let's do it like that. Okay, so there we go. 1, 2, 3, 4, 5, 6.5. 6.5. Just wanted to show you that this little shape here, I call this one the, don't know, some kind of squirrel or some kind of what is it? Don't know, some kind of dinosaur maybe. Now let's do this a bit quicker. So we have the small gear here, this one. This one is 2 times the small gear, and this one is 3 times the small gear. Okay, so can quickly do this. This is a half. This is rotation, half a rotation, half the circumference, half. This is plus 1, 2 times the half of 2. So a half, 1.5, 1.5, and this one was 3 times. Was it 3? No, it's 4 times. 1, 2, 3, 4 times. 1, 2, 4, indeed. So a half plus 1, 1.5 plus half of 4 is 2. So half, 1.5, half, 1.5, plus 2, 3.5. 3.5, we add a half, is 4. We subtract a half, 3.5, and we add a half, 4. So 4 rotations. Let's see if that's correct. There we go again. Oh. 1, 2, 3, and 4. Now, there's one more final thing I wanted to explain to you, which I started to understand when I was playing around with these straight gears and a big gear. So again, this big gear, move it rotating one time, because it's moving, or this circumference of this gear, it's exactly this length. Now the question is, if we try and figure this out for yourself, and then I will also give the video and explain what will happen when I pull down this one. So this one remains rigid. I'll pull this one down. Will it go here? So one time the movement, or will it even go here? So without trying it out, I will give you a moment to think about it. Think about path, adding path. In the rotating coin paradox, that we add rotation, and here we have a, well, we say translating coin paradox. That should give you some hint. Okay. If you found a solution, do the unpause, and I will give you the explanation. Okay, yes, the explanation. So we will just look what happens. Put it down. Ooh, and it's going all the way down. And indeed, so what happened? This sticky moved two times. And why did this happen? Well, you know, oh, let's put it like this, by the way, this may be even better. Maybe here, now it's completely in view, so here, now you can see it much better. Okay, so rotate this there. Now, why did it move such a long distance? Well, as you saw with the rotation, we have a rotation of the circle and we have a translation. See? Translation in this direction. So we add the complete translation. So we have the rotation part of the circle that moves this straight gear down the complete circumference, so the complete length of this straight gear going down. And then because the circle is also moving down one complete size of the, we have to add this one, see? So with this final thingy concludes the video, and I hope that somehow this made sense to you. Yeah, and I hope that it was fun watching this video. This is a weird dinosaur creating. Let's see. Okay, now, drop me a line if you like this video. And for now, goodbye. And I hope you have a better understanding of this of the rotation coin paradox, which probably is not a mystery to you anymore. Okay, bye bye. See you in the next video.